Hi, Chris here. We're going to do a video on complex calculations involving percentages today. And as you can see from the screen here, that involves compound interest, repeated percentage change, and reverse percentages. So, hope you've got the notes and stuff from the website, or if I've given them to you before, and we'll follow along. Exciting, exciting. Let's see. First one. So we're going to look at compound interest first. We did simple interest last year, and simple interest was the idea that if you invest money in a bank or take out a loan, that year on year you would accrue interest or pay interest on that amount. And last year we just used a simple formula to do that. We used I equals PRT, where I equaled the interest earned. P was the principal sum of the initial investment. So if you put down like £1,000, that was your initial investment or your principal sum, your P. R was your percentage rate of interest, not just the figure of interest, which is important because that's the bit that people got wrong if they're going to do anything, and we'll see that in the examples that come up. This time, that you're not just putting in the rate of interest, which is just a number, you're putting in a percentage, and that means involving taking in the 100 as well. And T was the time of investment. And if you were any good with algebra at all, you plug those values into your formula and out popped your answer. In fact, if I, with this, the only thing that was really difficult that was that PRT means P multiplied by R multiplied by T. And if you remember from last year, mathematicians are desperately lazy. They don't like writing down things that are unnecessary, so the PRT, it was shorthand for the multiplied. When those things are sucked together, then it meant they're multiplied together. So if we move on to the next thing, so compound interest, what's the difference? Compound interest is similar in that we still calculate the interest gained, but we do it year on year. So after the end of the first year, we calculate the interest that's been gained, and then we would add that onto the principal sum. So at the start of the second year, your new principal sum would be the principal sum and the interest gained from the last year. At the end of the second year, you would work out your interest on that amount, and you would add that interest onto the principal sum at the end of the first year. So they would keep rolling on. And this is how real life interest is calculated. And you repeat this process for every year needed. So how does this relate to the formula? Well, in many ways, if I flick back to the formula here, it takes one bit out of the equation, because if you're working on it year on year, you're still working at your principal sum multiplied by your rate of interest, but your time is always 1 for each year. So it's nearly like I equals PR multiplied by 1. So if we look at a worked example and see how this gets put into practice. The other good news about this topic is that it comes up in the calculator papers on GCSE. So you will have the aid of a calculator for most of them for the questions when they come up, which is a big thumbs up. So our question is Venetia, or I think it's Roger in the notes I put it in, because I don't know anybody called Venetia. And I meant to change it here, but I think you get the general idea. Venetia or Roger puts £800 into a savings account, earning 6% per annum interest. And per annum, for those that are not Latin fluent, is per year. Not that I did Latin in school either, but that's what it means. How much does she have after 2 years? Right. So, if I start off with this, I'm going to do, first of all, I'm going to do year 1. And in year 1, our principal sum is 800 quid. And our rate of interest is 6%. Our percentage rate of interest, sorry. Now, we need to change that into something, although you might have a percentage button in your calculator which you're comfortable using and all well and good, but for the practices of good maths, I like to change this into either a fraction or a decimal. And as a fraction, remember 6%, percent just means out of 100. So it's 6 out of 100. And again, if you pop that in and get the decimal value, 6 divided by 100, you will also get 0.06. So you would use your formula, I equals PR multiplied by 1. Well, I've done it the wrong way around. I should probably, let's not go crazy. Oh, let's rub it out. There we go. There's our rubber. Go back to our pen. Okay. I equals P times R. And the time is 1, like I said. So your principal sum is 800. We're going to multiply that by 6 or divide it by 100 or just multiply by 0.06. And if you're working with your calculator, I would stick to the decimal. It's much easier. And if I pop that into my calculator, 800 times 0.06, I should get £48. So at the end of year 1, on the £800, I've gained £48. So if I go to year 2, my new principal sum is going to be our 800 plus, even though it looks like a multiplied sign, let's make it a bit more definite, plus 48, which is going to give us £848. Right, and our rate is still our 0.06. If I go to work out our interest, it's going to be our P, our principal sum, which in this case is now 848, multiplied by, again, a rate of interest, which is 0.06. And again, if you pop that into your calculator, what you should get is £50.88. How much does she have after 2 years is the question. Well, that would take me 848. I would add on the £50.66, and our total, if I go to it, will be £898.88. And that's what the question's asking me. There's our result. Ta-da. These things don't want to work. I blame my big clunky fingers. And there's your answer, £898.88. And that's our first worked example. Now, you can pause the video, you can go back, watch that again, see if you can follow the steps. If I've missed one out when I'm talking through it, that's... hit me a rap in the knuckles, will you? But basically the same idea is the same. And you're still using the I equals PRT formula. But remember that T stands for 1 each year because you're working it out at the end of each year, and your term time for your interest is 1 year. So you would use, stick in your principal sum for the first year, which is your initial investment. In this case was £800. Our rate of interest is 6%, remembering that that's a percentage rate of interest and not just a number. So you're not putting in 6, you're turning that either into a fraction or a decimal, and I would suggest if using your calculator to use the decimal to 0.06. Then we can work out I equals P times R times 1, or 800 times 0.06 times 1 if you want. But remember, if you're multiplying by 1, then it doesn't really change anything. If I have 1 apple, 1 multiplied by an apple, still an apple. You know, you're not really changing it. When I do that, I got my £48. From year 2, I took my original principal sum, which was 800, and added on my £48 to get £848. Rate of interest was exactly the same, and I got £50.88. Oh, spotted it. An awesome mistake down here. This isn't £50.66, it's £50.88. Always important to check your work. See that? Happens. If I add £50.88 and my £848 together, I get £898.88, and that's what she has at the end of the second year. Okay, so worked example 2. You can pause the video if you like and try this one yourself beforehand, or you can just follow along with the video, copy the answer down. You'll get plenty of opportunity at the end to try some more of these yourself. Okay, so let's see how it goes. It's Amy invests £135 for 2 years at a rate of 4% per annum compound interest. How much will she have at the end of the second year? So we start exactly the same as we did before. Year 2, year 1. Should really stop and record again, but year 1, let's make a nice coloured one in. Our principal sum is £135. Our rate of interest is 4%, which, same as last time, we'll convert into a decimal and a fraction. So that's 4 over 100, and if I do 4 divided by 100 on my calculator, I do get 0.04. So if I'm working out my interest, I get my principal sum, which is 135, and I multiply that by the 0.04. And if I pop that into my calculator, I should get £5.40. So if we go to year 2, our principal sum now is the £135 plus the interest we got last year, which was £5.40. And if I add those two together, I should get £140.40. Our rate is still the 4%, so the 0.04. And our interest then will be 140.40 times 0.04. And if I do that, I should get the wonderful sum of, as I look at one I've made earlier, 5.616. Now, there's something wrong with that little figure there, but we'll come to it in a second. We want to work out how much she had at the end of 2 years. End of 2 years, she had £140.40 plus the interest of that at the second year, which is 5.616. If I add those two together, I will get 146.016. Now, as you probably realized, money doesn't go to 3 decimal places as that is there. It only goes to 2. So we have to round 2 decimal places, and we get 146.02. And that is our answer for that part. And our answer is £146 2p. So again, just stepping through the problem again. We'll have to do year by year. We'll do year 1, work out our principal sum and our rate of interest, percentage rate of interest, work out the interest. For the start of year 2, our new principal sum is the old principal sum added on to whatever interest we got, multiplied by our rate of exchange, and we add that on to thing initially, and we'll come at £146 2p. And if it's the third year, new principal sum for the start of the third year would have been £146 2p if you were rounding it, or 146.016, and carry on from there. All good. Right. Well, you're probably thinking this is a little bit complicated, or a little bit long-winded, because if you had to do that for 5 years, you'd have to be very, very organised, and you're working very, very sure of the method, and very, very sure in how you're laying it out. You would have year 1, you'd have a result. You'd have year 2, you'd have a result, and you'd be constantly adding back and forward, and it would be getting very confusing. There's nothing wrong with this method at all. However, there's a better way to do it. A quicker way to do it that will give you the answer straight away through one calculation. Bet you're glad you heard. Let's see what it is. Of course, I should say, there's questions in the Google Doc at the end, or the Google form, which you can try and submit, or you can do them as you go along, or you can just wait to the end, do them all at the end, and see how you get on. But this method that we're going to use to simplify it down is called repeated percentage change. Compound interest, like I say here, can get very long-winded, especially if you're doing it across multiple years. We can use this idea or theory of repeated percentage change to help make things easier. Now, we can follow some simple rules to do this, and it's a 3-step process to it. I'll explain it. I've left room in your notes for you to copy it down. You can do that as we're going along. So the 3 stages of this, and most of the rules that I'm going to give you, I'm going to try and give you in steps so that you can work your way through the steps each time when you're practicing these things, so that if you iterate and that, iterate and that, iterate and that, it might start to sink in a little bit. But we'll see how it goes. The first thing you're going to do is add the rate of interest to 100%. So if you think back to the last question, we had a rate of interest of 4%. We're going to add that to the 100%, and 100 plus 4% would give us 104%. We would convert 104% to a decimal to get what's known as the multiplier. Now, 104% as a decimal is 104 divided by 100, which will give you 1.04, and 1.04 would be the multiplier for our principal sum, or our initial amount of money. Third step is we use this multiplier as the new rate. So instead of using 0.04, we'd use 1.04. And the key part is we would multiply that multiplier by 1.04 for as many years as there is. Right. That's an awful lot of words to throw in together. Let's do an example to see how that really works. Now, I'm going to go back to the old example that we used in the first place. I thought this was a better way to do it. I put the rules for doing this at the side of the page, as you can probably see. So our good friend Venetia, or Roger. Now, I've probably decided that Venetia and Roger are the same person. While I've been talking here, Roger underwent a sex change, but to become Venetia, you know, you wouldn't go from Venetia to Roger, would you? You'd probably go the other way around. But anyway, Venetia puts £800 into a savings account earning 6% per annum interest. How much shall after 2 years? So we already know what the answer to this. We've looked at it previously. Let's see how it's done using this new method, and we'll follow the steps. If I go here, and we'll make sure our black pen is selected because that's much nicer. Okay, so our step 1 is we add the rate of interest to 100%. So our rate of interest is 6%, and we're going to add it to the 100%. If I add those two together, I get 106%. Easy peasy. Second step, convert this percentage to a decimal to get what's known as a multiplier. So to get the multiplier, we're going to take 106%, change it into a decimal by doing 106 divided by 100. That will give us 1.06. Third step, use the multiplier as the new rate. Use it and multiply by how many years the money is invested for. So our principal sum is 800. This is where we use our PR as before. Now, what we don't get the interest in this case, we don't get that. What we get is our final total. If we use it this way, and it's a very distinct difference, and it cuts out a couple of steps as done beforehand. What we do is we take our principal sum and we multiply by 1.06. Now, that's for the first year. If there's 2 years, we're going to multiply by 1.06 again. And to better illustrate this, I'll change the color. That's for year 1. That's for year 2. And what you get is £898.88. Or at least I'm quite sure. Let's see. Let's get our calculator out again. So I'm going to do 800 times 1.06 times 1.06, and that gives £898.88, and that is our answer. Okay, so you can see they get that directly rather than having to calculate the interest, add it on, new principal sum, calculate the interest, add it on, final answer. It just pops at the end. Let's see how this works with another example. Again, you can pause the video, do it yourself, but I will warn you, in this one, there's a slight difference to it. Okay? You're still with me? Okay. This one is, there are approximately 5,000 whales of a certain species, but scientists think that their numbers are reducing by 8% each year. Estimate how many of these whales there will be in 3 years. Okay, so it's slightly different from before. We'll go through our 3 steps. We've got it says add our percentage rate change to 100%. So we'll start out with 100%. And our percentage rate change in this case is we're going to add on -8. -8, you say, geez, what are you talking about, Chris? Whoa. Well, we're adding on minus. Well, in this case, it's reducing by 8%, so it's actually going to be smaller. In all the other previous examples, I've used examples where we would have money and rates and mortgages and loans and, you know, interest accrued on our account. Now, I'm going to use something where, you know, this calculation can be used outside of that scope. So, in this case, we're looking at whale population. I mean, a very common topic to come up, I think you'll agree. So, we're reducing by 8%. So, again, we're going to look to see what the percentage rate of change is, or it's going to be -8 from what we have. So, 100 minus 8 is going to be 92%. So the new year on year, there will be 92% of the original population that are going to exist in the world again. Okay, that's part 1. Part 2, we've got to convert this 92% into a decimal. So it's 92 divided by 100, which is 0.92. Third step is we're going to work out our calculation to give our final total. So we're going to get our principal amount, which is 5,000. That's our P, and we're going to multiply it by our multiplier. I'm going to call this our multiplier, because that's what we're trying to work out. That's what we call the result of the second step. So we're going to multiply by 0.92, and we're going to do it 3 times in total because there are 3 years. 0.92 times 0.92. And I'm going to pop this into my calculator because we get a rather interesting answer at the end. So if I do 5,000 times 0.92 times 0.92 times 0.92. I get 3,893.44. Now, there's something about that answer that's not quite right. Can you guess what it is? If you guessed that 3,893.44 isn't a whole number of wheels, you'd be 100% correct. If you guess something else, you can pretend that you were correct, okay? You notice that the question asks you to estimate the number of these wheels that have been 3 years. Now, part of the clues in the question there, like as you can see there, you get a decimal answer. We're going to have to round this to the nearest whole wheel. And the nearest whole wheel will be 3,893 wheels, because 0.44 is closer to 3,893 than 3,894. All good? All good? You can go ahead and try some of the ones yourself. They're in the Google Forms. Best luck with them. Like before, if you need help or something you don't quite get, like I say, I've given you two very different examples there. One with an increase, one with a decrease, to kind of give you some scope for what you could possibly get asked, or give you more subject knowledge, if you know what I mean, the type of question to be asked. If there's anything you don't understand, bring it with you into class and we'll discuss it. Okay. Okay, everybody, so continuing on our exploration of the percentages, we're going to do index numbers. And what are index numbers? Well, index numbers are a number that compares other prices to a set one, if you know what I mean. So a set price could be determined, you know, like record figures, right? So base everything around record figures. But that could be your base price, and then everything could be percentage above or below those record figures. Or it could be an average price. So over the last 50 years of data, the average temperature in Belfast or Lisburn in June 2013 was this. We would compare all other temperatures to that base number, or that base index number. So, as it says in the notes, an index number compares one number, usually a price, with another one. The figure that numbers are compared with is called the base. And the index number is a percentage of the base, but the percentage sign is left out. So the index sign, the base number, is always 100%. So the 100% mark is here. UK Retail Prices Index started at base 100 in 1987, and in May 2009 the Retail Price Index was 11.3. That means that average retail prices had risen by 11.3% between 87 and 2009 when that book was published. So no better place to do this than to look at an example. So if I do that, okay, so let's look at this example. It's one with a nice table and all, and you can use your calculator for it in exam, which is always good. In 2000, the price of a litre of petrol is 69p. The table shows the price index of petrol for 99 to 2003, with 2000 as the base year. So that's the year where they decided this is the 100%, this is the one every other one's going to be based off. Work out the price of petrol in 1999 and in the years 2001 to 2003. Give your answers to one decimal place. So let's look at this year by year. So if I get me pen, make sure it's appropriately coloured. Right. So the first year we'll look at is 1999. So if I go 1999, we'll look at that. So we know, I'll put this up the side, that our 100% is 69p. So we just need to work out for 1999 what 92% of that number is. And to work out 92% of the number, you do 92 divided by 100 and multiply by 69. And if I get me calculator, what I find is 92 divided by 100 multiplied by 69 is 63.48p. Or, to one decimal place, 63.5p. Do the same for 2001. Apparently it was a space odyssey that year. Apparently. Smart man told me that. So we're looking for 103% of this value, which is basically looking for a 3% increase on the 69p. So we're going to do 103 divided by 100 multiplied by 69. And that will give us 71 0.07p, which is 71.1p. Dead easy. 2002 is you're right. We're looking for 107% of that number. Which is 107 divided by 100 multiplied by 69. And that'll give us 73.83 or 73.8p. And last but not least, for 2003, I'm going to have 110% of, oh, that should be 69p. Plank. You see me doing this a lot, don't you? The more I write and talk, the more that I get wrong. It's 69. So that's 69. 110 over 100 multiplied by 69. Last but not least, if I do that, I get the nice round answer with no rounding needed of 75.9p. And there are your answers for each question. 63.5, that one there, as I colour in, 71.1, 73.8 and 75.9. And I think you'd be very proud of me for not making any jokes whatsoever in that question. Next one, something slightly harder, but it's still supposed to be within the realms of foundation, but I think it's slightly harder than that, if you know what I mean. I wouldn't expect to see it in a foundation paper, but apparently it could be. This one is, if I just change my, I think this is my pen, here we go. The graph shows exchange rates for the euro and the pound in 2008. So up the side here we have our exchange rates, or the value in euros of a pound, from 1.18 to 1.38, and then along the bottom is our months: January, February, March, April, May, June, etc., etc. along the bottom. So the first question is quite straightforward. It just asks, what was the exchange rate in January 2008? Well, that's this month here. And if I look up and across, that value is one above that. So we'll have to work out what each increment is. And if I count up and notice, I will see that each one of those increments is 0.01 of a euro, or a cent, as they might call it in France. There you go. So a cent more than 134 is 135. So in January 2008, the exchange rate is, for every pound is €1.30. Oh, 5. There's my euro symbol. Nice and easy. During January 2008, or using January 2008 as a base of 100, work at the index for December 2008. So that is, we can go back and say, well, that's actually our 100%, 135, and we need to find out what December 2008 is. The first thing we're going to have to do is work out what the value of 2008 is, and if I look across from there, it goes across to there, and that value is 1 above 1.18, which is 1.19. So we need to find out what percentage that is. So the easiest way to do it, I think, is probably turn that into a fraction. So what is 1.19 out of 1.35? I don't like fives, this pen. Oh. And as you see, we have a mixture of decimals and fractions there, which we don't really like, so I'm going to turn them both into pence, so to remove the decimal equally out of them. And we get 119 over 135, and to turn that into percentage, we just multiply the fraction by 100. And our answer for that, we will get 119 divided by 135 multiplied by 100 gives us 88.148 for the end of time. 88.148, 148, etc., etc., etc. We want the answer to one decimal place, I suppose, and we'll say that. Unless it says otherwise, we'll make a decision. It's going to be 88.1 to 1 decimal place. And that's about as hard as it gets. I mean, the basic principle is the same. You've got a base percentage, and you'll either have to use another percentage above or below to countermand what you're doing, or to make sense of what you're doing. Either get a new price or a new percentage. Okay. The last one we're going to look at is reverse percentages. So all the time that I've been teaching you, I've been teaching you how to do percentage of an amount. You've always, like, you find 20% of £80. A dress, you know, I wear loads of them. It costs £80. You've got to find what it would be if it was 20% off that price. And it's all the £80 always the 100%. So you find your 20% of that, and you can work off that. Now, what if you got a question a bit like this? A bike is reduced by 20% in a sale, but the sale price is given £135. You have to work out the original price. So in this one, you haven't been told the original amount at all. You've got to work out what it is, and this is what we call a reverse percentage question, or reverse percentage problem. Now, it's very like other proportion questions. It falls directly in the scheme of direct proportion, and for a quick reminder, direct proportion is the idea that things get bigger at the same rate. The easiest example I can ever give is going into the shop and buying a Mars bar. If you go into the shop and buy one Mars bar for 63p, if you buy two Mars bars, it's going to cost you another 63p, or it's going to be twice as much. If I buy 10 Mars bars, it's going to be 10 63p, £6.30, because the price of the Mars bar doesn't change. You're excluding the idea of multi-buy sales and all that kind of stuff, but that's what direct proportion is. So you're going to use that theory to solve these reverse percentage problems, and there are loads of different ways to do it. In fact, the way that I was taught, and the one that eventually went ding 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 in my head when I was, remember very distinctly, learning this when I was doing GCSEs and stuff, I knew how to do the various bits and bobs, and I know the struggles that an awful lot of you are going through, the difference between ratios and proportions and percentages, and you know, the different methods for each. How could I organise my brain, which bit fit with which? And a teacher ended up showing me a very language-based solution to it. So if you don't get this, then come back to me, and as you know, I'll find another way to teach the problem that's just for you. And if you want, I'll make you a movie on it. Is that a deal? Cool. Let's go. How to work at reverse percentage problems. So like I said beforehand, I would try and do these solutions so that you have steps to work through. Steps to work through so that you could get the answer. So the 3 steps you can copy down in your notes are this. Work out what percentage the final quantity represents. Divide this percentage by define 1% and multiply it by 100 to get the 100% figure. So it's just the same as other proportion problems you've done in the past. Let's see one in practice, because words don't necessarily make much sense unless you see them in action. So our first worked example is going to be a magazine circulation is 30% down on last month's figure. This month they sold 490 copies of the magazine. How many copies did they sell last month? Now, as you notice, we don't have last month's figure, which is the original amount, and it's very, 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 very common that in an exam people will misread this and find the 30% of the 490. Okay, so let's work through our steps, and I'll flick back and forward to get them. Work out what percentage the final quantity represents. So what does that mean? Well, what is the 490? What percentage does the 490 represent? 490 is 30% down on the last month's figure. Last month's figure is the original figure, which we assume to be the 100%. So for 30% down on that, we are 100 minus 30. So that's 70%. So we've worked out 70% of the magazines is equal to 490. Step 2. Step 2 says we have to work out, divide the percentage to find 1%. So if 70% is that 490, to get 1%, how do we get from 70% to 1%? We divide by 70. So the rules of direct proportion say we do the same to the 490 as well. Divide that by 70. If they get bigger or smaller at the same rate, we're trying to find out, if you want to think of it as 70 somethings cost £490, how would you find out what one something cost? Well, you would divide your 490 by the 70. And luckily for us, 490 goes into 70 a nice round 7 times. So we found out that 1% is 7, or 7 copies of the magazine. Third step is, if we know what 1% is, we multiply by 100 to get the 100% figure. So we take, for 1% is equal to 7, then 100% is equal to the 1% times 100, which is equivalent to, and equivalent is actually that one there, 3 lines together. Little bit of maths text speak for you there, to keep on throwing these little bits of notation for you. But equivalent is more like that, is equal to 7 times 100, which is equal to 700. So there were 700 copies of the magazine in total, and there's a way you can check using your existing skills, the ones you're very comfortable with. If you get the answer to be 700, how could you check it? Stop, pause. Have you got the answer? Okay. If you know it's 700, you could find out what 30% of 700 is. Take it away from the 700, and you should get 490. And sure enough, if you do that, that's what you get. Alright? Feeling a wee bit better about it now? Let's do another example. Let's go the other way. We've done a reduction. Let's do a positive. Worked example 2. After a pay rise of 4%, Kate earns $14,560. What did she earn before the pay rise? Okay. First step. Whoops. First step, we have to work out what her new percentage is. So if she gets a pay rise of 4%, then her new percentage, what is the 14,560 represents 100 plus 4, which is 104%. So 104% is equivalent to the 14,560. Okay. Second step, we've got to work out what 1% is. So how do we do that? To get 1%, it's going to be 104 times smaller than the 104%. So we're going to take our 14,560 divide by 104. And if I do that, I get 140. I'm pretty sure. Let's see, 14,560 divided by 104 we get 140. So we found out the 1% is equivalent to 140. So to get 100%, I've got to multiply my 140 times 100. And if I do that, I get £14,000. So her original amount of money was £14,000. She got a 4% pay rise, which was equivalent to £560 by the time the tax man, the nice insurance, the pension and all gets her hands on it. She's probably earning an extra tenner a month. God love you, Kate. And that finishes our complex calculations video. Hope you found it enjoyable. Again, make note of anything you didn't quite get or you didn't quite understand. Try the quiz, submit your answers before class. I'll have a look to see how you did. And best luck with it. Give me some feedback on it. And we'll see you in class. Until next time, see you later. Bye!